Hello everyone, welcome back. In this video I will finish about the least square estimator with C++ part. In this video we will talk about the code part, and this video I will mostly use these many matrix calculations, and I prefer use vectors instead of arrays because vectors are more useful. I like vectors. And why I will deal with this, because if we remember, there are some calculations which is kind of inverse or multiplication or cofactor finding because of inversing, taking inverse, and transpose adjoint also related with the inverse, determinant calculation. These are needed in the estimator of the least square. So I will use this, and in my repo in GitHub this is already ready, and I will use this also in my code part. I will just copy this repo. So basically you can copy this to your code. I already copied in here. Like this is show the result. This takes cofactor, determinant, adjoint, inverse, get transpose, and multiply vectors. Okay, in here I already prepared something because I will use for the representation OpenCV. Please don't judge me. There are many tools for demonstrating the results, but I prefer to use OpenCV because I like it. Uh, Basically, you can copy it. There is this code nothing doing but just giving the result of the force and length, which we see in the previous video. This example sample experience samples it's giving us, and I just basically take this and make a graph. That's all. And this is the graph which we see. I just didn't put the numbers, but this is the basically how this data looks like. Also, in this video we will totally talk about this uh, formula. Before we talk about this little, and people who are really interested with this, they can also check how we get this. It's also basement of this formula is very easy. People are interested, they can check this one also. And in my code part I will make in five steps. This one, first of all I will calculate this, then I will calculate this, then I will calculate this, and finally add all. After this add all, and we will get the results, which the results will be in here, k0 and k1. After that we can easily draw that line in our result. Date on data, how least square estimator line looks like. Also, I will share the code in GitHub again, and who people really just need the code, they can get it, and who are interested with how I wrote it, they can continue to this video. Okay, let's find the transpose first of all, and I will start in transport part. I will again need to define some vectors, because for matrix definition, let's define them first of all. In here I will use the type of double, because we need sensitive results. And first of all I will get transpose of A. In here I defined A as a if you check again the previous one, A is the data of how to say this. For example, 11, 19, 32, 44, 59, 74, 92. This is the data of the right side. Right side we take from there, because it's this actually. And the other side we are giving as 10, because it's the decimal 2-digit, that's why we are giving 10. And this is that part, and this part basically before also I told in the previous video, this is just this part, which is result, which is length. And now we need to transpose because of this x transpose. Then I will define in here that one. Secondly, square matrix. Let's say I will tell why I'm defining this in this name in the other line. Then also result. The other one we don't need to define in here. Let's basically calculate transpose A. In here we are using the get transpose function and just putting the A, and let's see the result is correct or not. And okay, in here, okay, we just transpose of this matrix is basically this one, and there is no problem in here. Okay, now the next step, let's continue. Now we need to multiply this transpose with this one, and I will define this square matrix, because if you wanna multiply a matrix with its transpose, you get a square matrix, which is the columns and the rows are equal to each other. Then let's call a multiply vectors function, and in here basically we will give first of all transpose, because in the equation transpose A comes first, then A, and let's see the result again, square matrix. Okay, then see again. Then as you can see, this is 2 and 2 columns, 2 rows as a square matrix. This is. Then next step, this one also done. Now we need to take the inverse of this square matrix result. How we taking inverse in is up to how I design the inverse function in here. Since I designed this as an unit to point to an vector, it means you need to give a vector already has some dimensions. So we will define these dimensions by ourselves, which is an empty matrix. Okay, then here first of all let's define it. That is also will be double type, and the name will be inverse square. Okay, now this is the part of how we are defining the size of that. The size will be equal to this square matrix result size. So basically we are writing square matrix first of all the 0, which means the column size, and not column, row, sorry. Then the other one will be the row size, the same row size we will define, which is vector again, and double. We are taking in here, if you take attention, we are taking as reference square matrix, so that's the point we need to take care. Okay, then by the way, I'm not sure again here, maybe this one columns or rows, I'm confused in here little. Okay, next step what we are doing is taking inverse function, not inverse square, what was the name of that? Okay, inverse, just inverse. We are giving the input, which is square matrix. Input we wanna inverse square, and this will give us the result of inverse square. And let's see the result. Okay, also in above I made it written the determinant, but basically the inverse of this is this one. Okay, let me close others. What else? Let's continue on this inverse we already take. Now we need to multiply this inverse again with the transpose A, which is in here x. Okay, let's multiply again like we did before, but we need to define this with something. Let's call it result. We already defined above, and here first of all we are giving inverse, secondly transpose A. Yes, transpose A we are giving, and let's see the result again. Okay, this is the result. And this is now last step. Last step is multiplying a doll with y. And let's call it result again, maybe. There is nothing wrong with that. Multiply vectors result with y. Y we defined in above this one. And let's see the result again. Okay. Now this is the our k0 and k1 which we found now. There is no problem. Okay. Now we get this k1 and k0 at the end of this equation. Now to see the result on the OpenCV, I will quickly write how we can see that in the OpenCV with OpenCV on the graph. Please don't make much attention. I just will do this for the for just to show the result how it looks like in the graph. Okay, first of all, I'm defining in here the just some x's because I will draw a arrow, so you can maybe skip this part because this is just for the showing. Okay, let's draw the line now. Almost done. Okay, let's define the arrow type. Let's make it red line. What's left tick. Okay, the rest no need, maybe. Okay, and let's see. Okay, as you can see in here, the first of all we define these points, we get this data, experience data, and after that the step of the equation we follow just with some matrix calculation, and at the end we get this line. Any data if you change, for example, in previous video I talked also, if you think all these dots, all this data as a human and this arrow as a rope, and they are pulling this to each other with the same power, and then we get this result. For example, if this is little in here, maybe it will be little flip to that part, and like that. Okay, this is just example of some spring example, and any data if you wanna use in 2D, I designed this example. Any 2D data if you want to continue, just change this input datas and output datas, you will get the same results like how I did. Then all you need to changing the datas. Maybe for demonstration, I know it's really difficult to using OpenCV in this one, but I chose that way. But you can skip this part and you just can give simply inputs and you can get the results also. Okay, it's enough for this video. See you in the next videos.